Okay, hello everyone. Day two. Hopefully this video will be a little shorter than the last one. I'll try to keep them around 20 minutes. The last one went a little long, so my apologies. Anyway, today I want to talk to you about a couple of things. The first off is parent functions and what a parent function is, and then we want to look at four different parent functions and then what family they belong to. And then the last thing we want to look at today is how do you identify what what family a function belongs to based on looking at this graph. And I think the easiest way to kind of tie this into something you may know is when you think about your parents or maybe even your grandparents. Your parents have certain traits, maybe the way their nose looks, the color of their eyes, the shape of their body, and you as children sometimes have some of those same traits. So maybe you look like your father, your mother, your grandmother, or an uncle, or something like that. That's the whole idea behind parent functions. Parent functions are the base function with none of the movement or special attributes to it. It's just the very basics, and then the children functions, or the child functions, are ones that might be moved around on the graph. Okay, so definition of a parent function. I got three little bullet points I want to put in here in this definition. The first one is functions that belong to the same family share key characteristics before we get to the definition. So functions that belong to the same family share key characteristics. And that's kind of what I alluded to earlier. You might have the same nose as your mom or dad or your grandpa or something like that. You may have the same eye color, the same lips, the same brow. Basically, you look like them. When you have functions that all belong to the same family, they all look the same. Some might be skinnier, some might be less skinnier, taller, but they have the same key characteristics. Okay. What we're going to look at today is what we call the parent function. Okay, and our parent function is the most basic function of the family. Okay? And the third thing I want to talk about is that what about the functions that are all in the same family? So functions, say this, functions in the same family are transformations of the parent. And we'll talk about transformations more in the next video. You may have done some of it already. But basically a transformation is you stretch it, shrink it, you move it around, up, down, left, and right. Okay? All right, so we're going to focus in on four parent functions. These are not the only four that are out there, but they're four that we're going to focus to understand the idea for this unit. The first family of functions is what we call the constant family. Okay, and the constant family, the parent function, or the parent rule, very simply, is f of x equals 1. Think about what a constant is. A constant is just a number. Okay. Now, what does this graph look like? Remember we talked about last video, f of x is the same as y. So this really is y equals 1 when we go to graph it. So if I make a few marks here, 1, 2, 3, y equals 1 is that horizontal line. Constant functions are always horizontal lines. Okay. The domain, we talked about domain, how far left does this go forever, how far to the right does this go forever. If it goes left and right forever, we say the domain is all real numbers. The range on this is pretty interesting. If you think about this, what are the y values for each of these points? What's the y value here? 1. Okay. What's the y value here? 1. So no matter where you go on this graph, you're always going to get a y value of 1, and so that's our range. Okay, so there's our first function, or excuse me, first family, the constant family. The next family is what we call the linear family. Okay, think about linear equations. The parent function, or the parent rule, is f of x equals x, or y equals x. Now what does that mean? Think about points. If x is 1, y has to be 1. So 1, 1, 2, 2, negative 5, negative 5. As far as the graph, what does that look like? It goes up at the 45-degree angle here, this way forever, and it comes back down. If you think about what those points are, 1, 1, 2, 2, 3, 3, negative 4, negative 4. Okay. What does the domain and range look like? This goes down and to the left forever, up and to the right forever. So for the domain, it goes down forever, excuse me, right, left forever, right forever, all real numbers. Range, it goes up forever, down forever, all real numbers. So there's your second function, family. Parent function, linear, f of x equals x. The third family is the absolute value, and we looked at that a little bit in the last video. So the absolute value family, the rule or the parent function, f of x equals the absolute value of x. Okay. What does that graph look like? Okay. If you look at that half of the graph, it goes from the origin, it goes out at a 45-degree angle. Think about that. You plug 1 in, you get an answer of 1. Plug 2 in, you get an answer of 2. 3, 4, 5, you get answers of 3, 4, and 5. But what happens when we go the other way? If I plug negative 1 in to this function right here, what happens? It becomes positive. So negative 1 gives me an output of 1. So my point is going to be negative 1 over and 1 up. And so what happens is you end up getting a V. Any absolute value graph has a V. Okay, this comes to a hard stop right there. Okay. The domain, how far left does it go? It goes up and to the left forever, and it goes up and to the right. So it goes left and right forever. All real numbers. What about our range? Well, what's this low point right here? This low point is 0, 0. And we're going to focus in on the 0 of the y coordinates, why I underlined it. And notice it's everything above that. So for our range, it's going to be everything above, which means greater than or equal to 0. Okay. And the last one we're going to look at, quadratic. Okay, dealing with a lot of quadratics this year. Its base rule, or its parent function, f of x equals x squared. Any function that the highest exponent is squared, so an x squared, if it's 3x squared, 5x squared, 8x squared, it's called a quadratic function. Now what does that look like? If I just quickly graph some points, if I graph 0, 0, let me draw some marks of in here. Going to do every other one. Okay. If I plug 1 in there, I get 1. If I plug 2 in there, I get 4. Same thing over here. If I plug negative 1 in there, I get 1. And if I plug 2 in, I get, negative 2, I get 4. Okay. This one looks very similar to this, our absolute value. The difference is the absolute value comes down to a hard V. This one, the quadratic, you want to curve it. Okay, don't have to be a great artist, but notice it comes to a curve. And we saw this graph yesterday. Okay, it curves. It does not come to a point down here. It comes smoothly through. Domain, this is going up and to the left, up and to the right forever. Key thing, left forever and right forever. All real numbers. And the range, greater than or equal to 0. This point right here is 0, 0. Okay, what should you know here? You should know basically this whole chart right down here. Okay, you should be able to recognize that with the back of your hand. All right, so what are we going to look at for the rest of today? It's a kind of a base set of knowledge. We're going to look at these functions. We want to identify what family these functions belong to, and then we want to compare the graphs of f to the graph of its parent graph. So what happened? Is it steeper? Is it less steep? Is it sloping down? Is it sloping up? Has it moved at all? Okay, so let's look at this first one. This first one is a straight line. Okay, straight line is linear. Okay, so flip back your notes if you're unsure. So what family does it belong to? It belongs to the linear family. Okay. What is the function, the base function? F of x equals x. Notice this is f of x. Has an x in there, it has other stuff. Okay? All right, now think about the f of x equals x function. Remember, it went up at a 45-degree angle like this. So what's different about this one? First of all, it has a negative slope. Okay, so it goes down. All right. It's less steep. It's not at a 45-degree angle. Okay. And if you remember from the previous page, and feel free to look, that the f of x equals x, our parent function, goes through the origin. This one goes through, what's that, 2, 4, 6, 8. So it's moved up. So it's moved up 8 units. Okay. Now, what about the domain and range? Has that changed at all? Not at all. Okay, you can see it still goes up and to the left, down and to the right, so it still goes to the right and left. So the domain is all real numbers. And similarly, the range goes up and down forever, all real numbers. Okay. All right, number 2. First of all, what family is it? It's the constant family, because it's a horizontal line. F of x equals 1. That's our parent function. Okay. All right, how did it move? You can see normally it's up here at 1. Now it's down here at -3. So what happened to it? It's down 4 units. Okay. What's my domain? It goes left forever, right forever. All real numbers. The range, though. What are all the y values? What's the y value here? What's the y value here? What's the y value here? -3 every time. So we say y equals -3 for our range. All right, third one. Notice this comes to a hard V. That's the absolute value. F of x equals the absolute value of x. Okay. Now, if you look back at the previous page, what does this function, absolute value of x, look like? It's a 45-degree angle this way and this way. So what happens here? It's just squeezed in. It's narrower. Okay. The domain, even though this goes up at a sharp angle, it still goes to the left forever. Still goes to the right forever. So our domain is going to be all real numbers. Our range, notice this low point right there is still 0, 0. Okay? Still 0, 0. So that means, and it's everything above there. Remember, we're just looking at the y's. So we say y is greater than or equal to 0. All right, for the fourth one, we know that it is quadratic. I'm going to write down here. Sorry. Which is f of x. Shift that up a little bit so you can see it. Equals x squared. Okay. What happened? Normally it's down here and it kind of goes like that. So it's moved up 4, and I'm going to guess over 1. Up 4, let's say, be more specific, let's say to the right 1. Notice we got a 4 and a 1 in that equation. Okay? Interesting. All right, notice in the first one, we moved up 8, we have an 8 in the equation. Okay? So just a little foreshadowing. All right, real quick, domain. Domain, it goes left forever, goes left and up, and it goes right and up, but it goes left and right. That's the key thing. All real numbers. The range. The range, we got to focus on our low point, which is right there, which is 1, 4. Since we're dealing with range, we just want to worry about the 4. That's our lowest point. Greater than or equal to 4. Y is greater than or equal to 4. And that's essentially it. If you can look at a graph, okay, like these 4, and you can tell me what family it comes from, what the domain and range are, you're going to be in good shape. Okay? So just real quick, sum this up. What do we want to do? So if we want to write a one-sentence summary to identify a function family, let's say this. Let's say you look at the shape of the graph and find which parent graph it resembles. So look at the shape of the graph. And find which parent it resembles. All right, and for the quiz, in case there's a little note quiz for you, Mr. Lamb is the youngest of 5 children.